perform the task within the timing constraints. So these are a few criteria that distinguishes the general purpose computing system. These are few criteria that distinguishes the general purpose computing system from the embedded system. Hope you understood with this. So now it's time to understand in brief the history of the embedded system. Now, if I just compare the information technology and embedded system and do a kind of analysis to find out which one was existing before. Now, it is embedded system. Embedded systems were existing even before the IT, information technology, had its place in the market. Now that means I can say embedded systems are much older than the information technology, because they existed well before the information technology made its place inside in the market. Now, yeah, with that, and initially when the embedded systems were introduced, they were designed using the vacuum tubes. I don't know whether you know how the vacuum tubes looks. Even the computer systems, the computer systems which were there during 1945, so they were made using the vacuum tubes. The major components of the computer system during 1945 vacuum tubes and relay memories. Now, because there were no transistors and diodes during that time, and all the major components were these vacuum tubes and relay memories. They were used as transistors and diodes. Now, if you want to know how these vacuum tubes look, you can go for you can just Google them and see how the vacuum tubes look. Initially, when the embedded systems came, so they were designed using the vacuum tubes, and how they were programmed. They were programmed using the low-level programming language. Low level, and same with the computer system also. When initially the computer system came, the modern computers, we say the modern computer era starts from 1945. Why 1945? Because prior to 1945 they were all mechanical computers. Mechanical computers. Now in 1945 the electronic computer started, and what kind of electronic devices were there in the computers which are there in 1945 were the vacuum tubes. And similarly with the embedded system, initially they were designed using the vacuum tubes, and they were programmed using low-level programming language. And to name few embedded systems, the first modern embedded system which was based on the vacuum tube was this Apollo guidance computer, and it was developed by Charles Stark at MIT in the 1960s, and followed by the first modern embedded computer, that is Apollo guidance computer. Next was Autonetics D17, which was developed in the very subsequent year, that is 1961. And later Intel for the first time developed a microcontroller called Intel 4004. It was a 4-bit microcontroller, and this was used in the calculator. Again, calculator is also an embedded system because it has the microcontroller, 4-bit microcontroller used. This was the Intel 4004 was the microcontroller used in the calculators after 1960, 1961. So later, after 1961, we had this first microcontroller from Intel named 4004. It was a 4-bit microcontroller used in the calculators. And later in 1970s, even automobiles started using the microprocessors to control this fuel air mixture within the automobiles, and also to timing the engine. This is how even the automobile started using the embedded systems. And then the first microcontroller, this TMS-1000 was developed by 1974 by Texas Instrument. And this microcontroller consisted of RAM, ROM, all these things, because all these things because microcontroller, I have already told, it has its own memory, it has its own peripheral, it has its own codes, everything. Now this was the TMS 1000 was developed in 1974 by Texas Instrument, and this microcontroller, the first microcontroller to have its own RAM, ROM, and also the clock circuitry. Now what is this clock circuitry? Because this is the circuitry which supplies all the clocking requirements of the microprocessor, because microprocessor to perform anything it requires the clock cycles, and this is the circuitry which is responsible for supplying all the clocking requirements of the processor. And inside the circuitry you have a special device called as quartz crystal, which is responsible for generating all the clocks required by the processor. And the quartz crystal, it oscillates with a well-defined frequency. Now in 1990, Intel again, earlier it has introduced a 4-bit microcontroller, that is 4004. In 1990, Intel introduced one more microcontroller that is called as 8051 microcontroller, which is an 8-bit microcontroller, and these microcontrollers were widely used in the laser and inkjet printers. And later in the 1990s, the small pagers came into existence. I hope some of you, or the majority of you, know the pagers. And later, the 2000, in the year 2000, the cell phone popularity increased, and the cell phones use many coprocessor for digital signal processing. And I don't have to tell much about the cell phones. They gained popularity in the year 2000. They started with very basic handsets, and these days we have the smartphones and iPhones, which are the most sophisticated cell phones. So that's the history of the embedded system. With this you understood, the embedded systems are quite older than compared to the information technology. And initially the embedded systems were designed using the vacuum tubes, and a low-level programming language was used in order to program the embedded systems. And you understood the first modern embedded system, that is Apollo guidance computer, and when Intel developed the microcontrollers, and this from that to the small pagers, and finally with the cell phones. Now we are about to discuss the classification of embedded systems. Now embedded systems can be classified into 4 basic types. One is one classification I can make it on the generation, that is called as generation based classification, and the second classification is based on the complexity and performance based classification, because here the classification is purely done based on the complexity and the performance of the embedded systems. And the third classification is deterministic behavior based classification. That means how the embedded systems are able to perform the task within the rigid timing constraints, how well they're able to perform the task within the rigid timing constraints. So that we call it as deterministic behavior based classification. And the last one is triggering based classification. That means the embedded systems which perform their task based on the demand by the other systems, or when there is a triggering by the other systems. Now, but the syllabus restricts only these 2 basic classification. We are not going to discuss these 2 classification, deterministic behavior based classification and triggering based classification. Now we will be focusing more on the generation based classification and the classification that is made based on the complexity and performance. Now first we'll understand the generation based classification. When I discuss the generation based classification of the embedded system, it is something like this: first generation embedded system, second generation embedded system, and third generation embedded system, and finally the 4th generation embedded system. We are at this right now, the 4th generation embedded system. Now what is the first generation embedded system? In the middle column I have the description. Now, the first generation embedded systems were using sometimes they have used 8-bit microprocessor, and sometimes they have used even the 4-bit microprocessor also, and the controller like 4-bit microcontroller 8085 so were used, and the hardware circuitry was very simple. It was not that complicated, and assembly level programming language was used to build the firmware. Now, this is a short description of the embedded systems which are there in the first generation, and where the applications are, where these things were used. Now, they were used in digital telephone keypads. So I don't know whether you have seen the landlines, the small keypad which was there inside the landline telephone, and the stepper motors also. Now, we have the experiments on this, even the one lab experiment on the stepper motor. When we go there, we'll be discussing, you'll understand what is the difference between a stepper motor and an AC motor. Now, all these things we'll be discussing later. Now, stepper motor is the one which you can control. That means now I want the stepper motor to rotate 90 degree or 60 degree. I want to make it to rotate two rotations, or I want to make the stepper motor rotate 180 degree clockwise and 180 degree anti-clockwise. Now, all these things you can do. And stepper motors are most widely used in majority of the applications. For example, robotics, you have to use the stepper motor for making the robot to move its hand, move its leg. Even the stepper motors are used in order to make the robot move his eyes, heads, all these things. Everywhere the stepper motors are necessary. Not only in the field of robotics, and the stepper motors are also used in majority of the other fields as well. Now, we'll be discussing later much on those things later. Now, the second generation, quite little higher embedded systems, they use, instead of 8-bit microprocessor, 16-bit microprocessor and 8-bit microcontroller, and these embedded systems are much powerful than compared to the first generation embedded system, because they are based on the 16-bit microprocessor and 8-bit microcontrollers. Now, where they were used, or the example, they were used in the data acquisition systems. So they were used in order to, data acquisition systems are nothing but the systems which are used for collecting the data or gathering the data, such as ADC, analog to digital. Say you have some data which is being sensed from the sensors, and it will be usually in the form of analog data. Now you can convert that into the digital data and store it for the further analysis and making decision. Now, another important such system is SCADA, that is supervisory control data acquisition system, which is most widely used in the industrial applications in order to collect the data, gather the data. Now, third generation, obviously they started using the 32-bit microprocessor and 16-bit microcontroller, and here this third generation embedded systems are domain specific. That means each one of the embedded system used to look unique from one domain to the other domain. And the best example what I can give is the robotics. So robotics, which the many industries started using the robotics for doing the work at a much faster rate, and even also to reduce the manpower. Now, one such example is the robot which is used to pick the object from the conveyor belt, and the robot which to distinguish the objects itself, and the robots which are used for packing the objects or the items. Now, fourth generation, they started using 64-bit microprocessor and 32-bit microcontroller, and even the concept of on-chip, system on chip, and multi-core processors were evolved, and they are more complex and very powerful embedded systems. For example, you can have the smartphones are the best example for the fourth generation embedded systems, and even the iPhones also. Now that was the classification which was done based on the generation. Now we are about to discuss the classification which is made based on the complexity and the performance of the embedded system. Now based on this, the embedded systems are further classified as small scale embedded system, medium scale embedded system, large scale embedded system, and even you can also call them sophisticated embedded systems. Now what is a small scale embedded system? Basically they use 8 or 16-bit microcontroller, and they involve very little hardware and software design complexities. And the tools which were used in the small scale embedded system development for the simple editors, assemblers, and integrated development environment was used. Now, medium scale embedded system, they use 16 or 32-bit microcontrollers, and some used the RISC processors, and some used the digital signal processors also. And this type of embedded system have both hardware and software complexities, a little higher than compared to the small scale embedded system. And the tools used here in the small scale embedded system, you are using the simple editors with the assembler to manually assemble the programs which are written for the small scale embedded system, and there were simple integrated development environment were also there. Now the tools used in the medium scale embedded systems, they started writing programs in C, C++, Java, Visual C++, and they started using the RTOS, also real-time operating system. So debugger was there in order to track the program and find out the position or the place where the program is not behaving as intended by you, and simulators were also came. Say for example, Keel IDE is a simulator. Such things came. Now the last one is the sophisticated embedded system or the large scale embedded system. This system were based on the 32-bit or a 64-bit microcontroller, and these systems have massive hardware and software complexities than compared to the small scale and medium scale embedded system, and especially these sophisticated embedded systems are used especially in high performance mission critical systems. Say when I say high performance mission critical system, so the application of this sophisticated embedded system is in the air traffic control system. It is there in used in the satellites, and it is used in the military applications. Since they are used in high performance critical system, so this sophisticated embedded system, they use the application specific integrated circuits and the programmable logic arrays. So I don't know whether you have understood the programmable logic arrays in the previous semester in the electronic circuits. So they have the AND gate plane or the OR gate plane, using which you can program the designed desired Boolean expression, or any given expression can be programmed using the programmable logic arrays, using the AND logic plane or the OR logic plane. It is just a plane using which you can do the execution of any expression. And where they are used in flight landing gear systems, satellites, car braking system, military applications, and robots. So hence, since the application of these devices in high performance mission critical systems, so they are called as sophisticated embedded systems. So that was the classification of the embedded system. We understood in detail the classification of embedded system based on the generation, classification of embedded system based on the complexity and performance of the embedded system. Now, what are the major application areas of the embedded system? As I already told, you cannot make the list of the domains or the areas where the embedded system is not used. now all the domains embedded systems are used. So example, consumer electronics, you have the cameras and many examples you can give for the consumer electronics, cameras, video games, etc., Walkmans, etc. Now household appliances also, there's a major application area, because you find the embedded systems inside the televisions, you find inside the DVDs, in the washing machine, refrigerators, and then the microwave ovens, etc. Many are there. You can make a huge list of household appliances that are using the embedded systems. And home automation and security systems also. Air conditions are there, home automations, and the smart lights are also there. Sprinklers, which are used in the agricultures, intruder detection alarms, and fire alarms. Many more are there. And then automotive industry, as I already told, majority of the automotive industry are using the embedded systems. Say for example, ABS, anti-lock braking system, engine control system, ignition, everywhere. And telecom, cell phones, the switches, handset, multimedia applications. Many things are there, and computer peripherals also. Say for example, printer also you'll find embedded systems, scanners, fax machines, everywhere it is there. And networking system, when I take the network routers, switches, hubs, firewalls, you'll find the embedded systems. And many of the healthcare devices, say for example, many scanners, EEG, ECG machines, so these are all based on the embedded systems. And measurement and instrumentation, say for example, digital multimeters, which I've used in the previous semester, is also an embedded system, because it has the microcontroller, the microprocessor inside it. Digital CROs, which I've used in the previous semester, and even it's used in the banking and the retail. The ATM machine is also an embedded system, and the machine that is used for the currency counter is also an embedded system. And this is the well-known embedded system, again POS, and majority of you have seen it, the point of sale machines, the machines through which you make your online payment through the cards. And then the card readers, say for example, again the barcode reader, which is used in the majority of the malls, smart card readers, and majority of the handheld devices. And the pictures are also there. You can have a look of the pictures. Now, in the previous slide, you understood the application areas of the embedded system. Now, what is the major purpose of the embedded system? Now, they are designed to serve one specific purpose, or a combination of the following tasks. I'll show you in the next slide. And these are all the application areas of the embedded system, which we have already understood. Yeah. Now, the main purpose of the embedded system is to perform one or a combination of these things. Now, one purpose of the embedded system is to collect the data, gather the data. When I say the data, it can be a text data, it can be audio data, it can be video data, and even it can be the electrical signals also. Now, all this data it can collect, and you can have embedded system for storing them, and if you want to represent them in the different formats, even the embedded systems can do that. And data communication, even embedded systems can collect all these things from the external world. Embedded system can collect all these things and store, and then they can represent in the format that is required from the external world. When I say external world could be anything from a simple sensor to another embedded system, or even a computer system also. And data communication, after collecting the data, storing them, and representing, even the embedded systems are capable of transferring the data from one end to the another end. And then data processing. Now, not necessarily collecting the data, storing them, converting them from one format to the another format. Even they can do some kind of processing on the data, and after processing they can monitor. They can see the state of the data by monitoring, and even so they can control also. And control in the sense they are capable of modifying the state of the variable. Here, when as a monitoring, they can only read the state of the variable, and they can produce the output based on that state. But here, when embedded systems which has the capability of controlling, has the potential to modify even the state of the variable also. So that you'll understand in a short while. And application specific user interface also. These are that means you can use embedded system in order to provide an UI, user interface, that is specific to a particular application. Now, all application will not have the same kind of user interface. The user interface varies. Say for example, the user interface which is there inside the video game, user interface which is in the bank ATMs, the user interface which is there in the cell phone. The UI, the interface through which the user interacts with the embedded system varies from one system to the another system. So these are all the purpose of the embedded system, and we'll discuss each of them in detail now. Now, the first purpose of using the embedded system is to collect the data, store the data, and represent the data. Now, the systems that are designed for this purpose, for collecting and storing and representing the data, so they perform the acquisition of data from the external world. Now, when I say external world, it can be a simple sensor, or it can be another embedded system, or it can be from the satellites also, or it can be from the other computer system also. What they do, they perform the gathering of data from all these external sources. Now, data collection is usually done for why you're doing this, for storage. Now, what is that you do after storage? You analyze the data. Now, after analyzing, what is that you do? You manipulate the data, and even you can go for transmission, distributing the analyzed and manipulated data across the world for the users to use. Then when I mean data, it is all kinds of information. Data can be a text data, voice data, image,